Hello. Today we will talk something more about the image and the matrix. Last time we already talked about an image is composed of different pixels. A pixel has two things. One is the coordinates, also the pixel value. So for each pixel, it has a pixel value. If we organize, let's get the pen. If we organize the pixel value, we will get a matrix. For example, for this pixel, it has a pixel value 170. For this pixel, we have value 238. Also for this pixel value, we have this value. Also for this pixel, we have this value. So for this kind of matrix, so also sometimes we call them image. So in the future, we will confuse the matrix of the pixel value with the image itself. Because for image processing, we just need to know this kind of pixel value. Okay? That's for the monochrome image. One monochrome image corresponding to one matrix. So sometimes we call the monochrome image also the gray image. For color image, in fact, we talked the last time, we have three matrices corresponding to a color image. Each image represents its pixel values in different components. For a color image, we have a red component, so we have one matrix to represent its pixel value. Also, we have a green component. Also, we have a matrix to represent its pixel value. We also have a blue component, so also we have a matrix corresponding to its pixel values. For example, this is an image. Okay, if we zoom in, you will see the small rectangle there. So each small rectangle is a pixel. Because this is a color image, for each rectangle, we have three values. One value means the red. The second value is green. The third value is blue. For example, for this, let's talk about for this one. Okay, for this pixel, we have a value 128 for the green component. Also, we have 247 for its red components. Also, we have blue pixel value. So for each pixel, we have three values. When you show on the screen, in fact, the color showed for this pixel, it's combined the red component and also the green component and the blue component. That's three basic color. Then we'll show the color of this pixel. For other pixel, the same. For example, for this pixel, okay, 1, 2, 3, 4, okay, then corresponding to this one, okay, for the red components. Also, the blue is for this one, and the green is for this one. So, if we organize the pixel values based on the red, green, and blue components, then we will get three matrices. The size of these three matrices are the same as the size of this image. So you always memorize this one. For a color image, means we have three matrices. For a gray image, we have one matrix. So in the future, if we talk about one matrix, we say, oh, this is a gray image. We talk about three matrix, that's generally we means a color image. So we will intentionally confuse the image with the matrix. Especially for image processing, we really care about is the pixel value matrix. We don't care about the original image. Okay? So we already have talked about how to read and display the image. Read the image, that's read the pixel value from the original image to some matrix. The A have two meanings. For gray image, it's just one matrix. Okay? If for a color image, in A, we have three components there. How to get the three components, we will talk about later. First, let's talk about how to display the color image. There are several ways can be used to display the color and gray image. In fact, this one can display color, this one displaying color, this one also display color. Also, this one also can be used to display gray image. We will talk them one by one. There is some difference here. For the first one, we display some image. So each element of A specify the color for one pixel of the image. Okay. In fact, if you guys know later, A in the cell, that means RGB. That's one pixel value. Then the second one is also RGB. Okay. The third value also RGB. That's for each one has three values for A. Okay. Also RGB for the second row, first column pixel. Okay. That's this kind of vector. In fact, it's composed of some vector. Okay. So A is a color image. Each pixel composed of three components. So there is some difference among this kind of display. Sometimes they will display the coordinates, sometimes no. Okay. Sometimes they will display the full color range. For example, for this one will display the full color image. What do we mean full color? If the color have 256, okay, that's the setting for the screen. It has 256 colors. But the image itself, for example, A itself just have 64 colors. Then when you display, use this one, okay, scale. Then they will extend the 64 colors to the value 256. But for the first one, it just displays the 64 colors. For this one also is a little different. For the difference, I will not talk in details. You guys need to go to the website to test the difference there. Okay. Now let's have some example. I have example here. For example, I save the image, color image, in here. Let's show. Okay. I save the color image here. Okay. It's 10. C10 teach 2019 directory. For example, I have a color image here. Also, I have gray image here. Let's show how to display this image. Okay, I use three ways. Let's first start the MATLAB. It takes some time. If you guys see here, I have three ways to display. You guys will see the effects on the display. Okay. So you can use the new script to create a script here. For example, to read the image, you first write image read, okay? But you want to read in the matrix A, image read, okay? Then single quota. The file name, we know the our file is in this directory, so you put the directory here, okay? Then the image name color.jpg, that's our image. Then put the single quote here. That will read the image in this directory. The name is color.jpg into matrix A. In fact, if you require, we have some bunch of image here. Okay, color 1, and the course 1 JPEG, download JPEG, and the grade JPEG. Today we will use the color.jpg, then the grade.jpg. Okay. So after you write this one, you want to display it. You can use several ways. One is just use image A. Okay, that's one. You can show image A in figure 1, so you should put figure 1 here. Then figure 2, you will use image SC, scale display. Also, you can use figure 3, image show. Okay. Then you can save it. Save it to this directory. You can, okay. For example, let's see. We have some name. For example, test2. Okay. After you save this directory, you need to execute the commands in this directory. For example, you can cd to go to that directory. Currently, you are not in this directory. For example, you can use LC to list, or you are not in this directory or not. Okay, you are already in this directory. Okay, let's see whether we have the test2 there. Test2 is here. Okay, execute, just type test2. Okay, let's see what's happening, whether there is some error or something. Okay, see, show up. See, you guys, it shows 3 figure. Okay, if we compare these figures, what's the font here? That's get use the image. Okay, that's get use the image SC scaled. Both of this one you did not found difference. You show the color image here. Also, you show the coordinates here. But for this image, you found it show a little small. You can enlarge it. Okay, but there is no coordinates. That's in the default case. Okay, these 2 image display function will show the coordinates, but this one is not. But you guys see here, the image shows the screen almost the same. Okay, so that's tell you how to use these 3 functions to show the image. That's for the display the color image. In fact, how to get the RGB components? Because the RGB components are in this matrix. If you check the size of a matrix, you can size 8. Okay, see here, you guys see 3 here. That means we have 3 matrices in this matrix A. Okay, so the height of this matrix is 183. That means the height of the image. The width of the image is 275. So we have three components there. That means it's a color image. If you guys see here, also show the S information. You can click it to see. Okay, see, that means they will show the first matrix, means the R matrix. Then they will show the second matrix for the it's a little difficult, but we can show in other way. Okay, So this matrix, okay, A, just partial of A, we get the R components, use this one. Then get the G components, use this grammar. And the blue components, use this matrix. So in fact, this matrix is not a two-dimensional matrix. A is a three-dimensional matrix. Okay? So that's how to get RGB components. You can just directly copy this one, okay, to the Windows. Then you get the RGB, okay? See? R, size of R. You can check the size of R. Oh, I'm sorry. See? That's one matrix, okay? There is no 3 here. Also the same G, the same. Oh man, I always made a mistake. Okay, G and B. Okay, if you display RGB, that will be gray image. Okay, for example, you will display R. There should be, see here, okay? That's a gray image. So the one components corresponding to one gray image. That's for the RGB components. That's for display a color image, okay? And how to get the components of the RGB. How to display a gray image. In fact, when you this gray image, the same, you can use this kind of 3 there, okay? For example, you can change your code. For example, you can first you can comment this one, okay? That means they will not. We still use a test 2, okay? You just copy this one. Then change it to gray image. We have a gray image there, okay? Gray image. For default display, try to use image show, okay? Don't use other 2. I will explain why. You can change this one to 1, okay? Other change it to figure 2 and figure 3. Then you save, okay? Then you test 2. See, that will display the gray image, okay? Let's see how to display the other 2. What's happening? Let's see, okay? Then test 2 again. Okay? Did you guys see what's happening? It's a gray image. You use image show, they will display a gray image. But use image and image SC to display. That's a color image. What's happening? But this is a real gray image, but display is color image. In fact, this is related to the color map, okay, for image display. First, talk about what's a color map. For example, color map is a n by 3 matrix. Let's go to the pen. For example, this one is 1, 2, 3, 4, 5. It's 5 by 3. Another second color map is 1, 2, 3, 4, 5, 6, 8. It's 8 by 3 matrix. What's these 3 numbers mean? You guys already guessed. These 3 means the first one means R, the second one means G, the third one means B. Okay? For each row, it has 3 components, RGB, RGB, RGB. Same for this matrix. The first column is R components. Second column is G components. The third column is B components. Okay, so that means each of the row means one color. Okay, one color. Different colors means, okay, the first one is one color. Okay, it's some color. Okay, one color. The second one is another, also is one color, but another type of color. Okay, there are a bunch of color. Because when you show the image, you need to show on the screen with different colors. Okay, so that means when you display a gray image, first you need a color map. Why? Because on your screen, when display your image, it's use the color to display, not use the gray to display. Always have three values. For example, your gray value is from 0 to some range, for example, to n range. Gray value 0 should be corresponding to the RGB, which row? Corresponding to this row. Then the second one can be corresponding to this row or something. Okay. Then the third, the 2 also can corresponding to this one. 3 also can produce this one. Then 100 perhaps corresponding to this one. Then 121 perhaps corresponding to this one. Okay, that is meaning to one map. Okay, then n perhaps corresponding to this one. Although you have n gray values, but we just have 5 colors, so different gray values can be displayed by these limited different colors. Then we'll show on the screen it's a color image. Because a gray image is a specific case of color. When the R equal to G equal to B in the color map, then the image will display as a gray image. So if you really want to display as a gray image, so when you design the color map, then you can display the color mapped R components and G components are the same. For example, this will be display a gray image. Okay, okay. Because the RGB components are same, RGB components are the same. Also this one, RGB components are the same. Okay, that's if you use this color map to display, the gray image will display as a gray image. Okay, but the color map is not a gray color map. That will display as a color image. That's you guys show there. So when you use the image show, they just use the color map called gray. Okay, see here, that's the color map name, gray. See guys here, for the gray color map, the RGB components are the same. Did you guys see here? This one, the same as this one, and also this one, and it's this one. That's for this one, they automatically call the gray, okay, color map. So you will show it's a gray image. However, for this one, their default color map is not gray, it's color map. Okay, default color map. See the default color map is here. Okay, the R components, G components, and B components are not the same. Okay, that's they will display as a color image. Example, for the image 2, you want to display as a gray, you can do this way. Okay, first display this one, see it's color. Then you use a color map. To use the gray color map called gray, see here, color map gray. Let's see what's happening. You guys see what happened? It looks a gray image, but it's not we expect for why? Because the gray image, okay, it has different choice there. You can use 64, okay, that means 64 value to display. Okay, let's see. Color, oh, I'm sorry, should be color map. Okay, color map. Oh, first you need to display. Okay, first you need to display. I'm sorry. We just remove this one. Okay, we can copy this one. Okay, we first display the figure 2. Okay, this is color. Then you use the 64 to see what's happening. Okay. See, that's this one. Then you can change the color map to 256. Okay, let's see what's happening. See, that's correct. That's for the gray color map. Also, there will be have bunch of choice there. But in the default for the image show, they automatically use the gray 256. Okay, the same for this one. Also do the same things. You can see figure 3. Okay, let's see. It's color. However, we use the color map is this one color map. Okay, replace the default color map. Let's see figure 3. Okay, figure 3 also correct. That means when you display a gray image, you need to select the correct color map. But if you don't care about the other two things, for example, I don't want to use this one. If you just use image show, there is no this issue. So generally, we just use the image show A to display the gray image. Also, sometimes when you display the image, you can put a color map here. Okay, use the image show. For example, you want to display, let's go to the MATLAB. Okay, image A, we put a figure 1 here still. Okay, use the image show A color map with you gray 64 you will show. Okay, see figure 1. There is some issue here. Image show gray 64. Oh, I'm sorry. Semicolon. Okay, see, it's this one. But if you display use 128, that's a little difference. Then you use display them 256. See, let's go to correct image. Also, you can use okay, that's become dark. Okay, that's use different color map display. So in fact, the color map is just the map the gray image to a color image. Okay, so for example, you have a gray image A. Okay, gray image A. This is the pixel value. When you really display, you need to use some color map. In this color map, if the RGB components are the same, they will display as a gray image. If not, they will display as a color image. Let's see this image. Okay, this A is matrix. As I told you, we already treated matrix as image. So A, we use B here because we already have A. So we will not confuse with our example here. Okay, let's define the B. Okay, B is matrix, also is a gray image now. Also, we defined our own map. Okay, see my own map is here. Okay, own color map. let's put in my map. Okay, that's I define my map here. Let's see. Okay, my map. See guys, my map. You can find the map, my map value here. Okay, my map. Okay, then you display, use image show. Okay, then be my map. We put it in figure 4. Okay, figure 4. See here, that shows a small image here. That's color image. Because in the color map, the value are not the same. However, if you guys do this way, okay, for example, I design my color map, all of them are same, okay. You can automatically define some color map. That's the first row. See, RGB, the value are the same. The second one, also we can put RGB, the same. Okay, that will be displayed as a gray image. Because your RGB components are the same. Okay, now you can display image show B. Okay, then my map 1. Okay, let's see. Okay, that's also showing the image 4. See here. Now you guys see this is a gray image now. Okay, it's not color image, it's a gray image. See here. That means in order to display as gray image, the RGB components must be the same when you define the color map. So one thing you guys see here, the color map, the value must be between 0 and 1. That's important. Must be 0 and 1. How does it display the image B? In fact, when display the image, first they get 0. Okay. After get 0, let's get the pen. After it get 0. Okay, that's the gray value is 0. Then they found from the table. First come to or is 0. Or they will say this pixel value will be displayed by this color. Okay, then go the second is 1. Then found the 1 from the table. Okay, that's 1. Then this pixel they will display by this color. Then you found the other thing. For example, this one is 2. Then they will found in the table found 2. Then say this pixel value, okay, will display by this color. The same for 5. Okay, for pixel value 5, they will go to found here. Okay, in the table. Then they get found there. Use these colors to display this pixel value. Okay, so that's why display gray image. In fact, there are many built-in color maps in MATLAB. There is this name jet, HSV, hot, cool, summer, autumn, winter, gray. Gray that we often use. Bone. How to get the value? That's much simple. You just need to type the name of the color map. For example, winter, winter they will show, show the color map. Okay. And also autumn, they show the map. Summer, they show the color map. Okay. Everything they just showed is here. So just need type, you get the built-in color map. Also, you can display, use the summer color map. For example, image show B to remember, then use autumn here. Okay. Okay, then they show in the figure 4, that's the autumn. Okay, they show it's like a red. Then also you can use winter. Winter they show, see what is the same or not. Okay, let's go to figure 4. See, that's winter. Winter is just more blue. Summer, let's also show the summer. Okay, use the color map summer to show. Summer is more green. When they set this color map, they based on the season. Okay, how to set the color map? Just use color map. That's we already done. We just say the color map, my color map or something. Also, how to set the current color map to the default color map? Just color map default. Because you always change the color map, you use the color map. You can go back to the default. You can use color map default. Also, there is want to retrieve the current color map. We just use CMap equal to color map. That's okay. Okay.